whoop, whoop. All right, it's time for us to get to our, that's coming in a minute, but we got to do this first. Our warm-up, and don't forget to write down your learning target, which is I will solve systems using elimination. Elimination. And we're going to do that using two types of elimination, addition and subtraction. Awesome. I will solve systems using elimination, addition, and subtraction. Okay. Go ahead and do the warm-up. We're starting that. I'm going to pour my cup of coffee. Usually I just pause it to make the video shorter, but you know what? I can use a cup of coffee this morning. I don't know about you guys. Maybe it's not morning when you're listening to it, but it is for me when I'm making it. Oh, that's some ASMR for you. Awesome. Pause this if you need more time. And without further ado, let's get into this. Okay, simplify each expression. We got to distribute. Simplify does not mean solve, by the way. Simplify just means make it simplest form. So I'm going to have 5k minus 15 minus 7. Combine like terms, which is minus 15 minus 7. So that is 5k minus 12. Awesome. Same thing here. I'm just going to distribute. 24 minus 6v minus 12v squared. Now, there's an argument to be made that this probably needs to be put in order, descending order. So I'm going to do minus 12v squared minus 6v plus 24. However, I would accept either form. I'm just saying eventually we'll want to do that. Okay, looking at here, again, same deal. Distribute 3a plus 6 minus 5a plus 3. Combine like terms. We can combine the a's and combine the numbers, right? So negative 5a and 3a is going to give me negative 2a. And 6 plus 3 is plus 9. Probably should square my answers, right? Tell the difference between circles and squares. And last but not least, don't forget, when we distribute, use the sign in front of it as well. So this is 12, and then negative 3 times 2t is minus 6t. Negative 3 times negative 7 is plus 21. We can combine the 12 and 21. What do we get? We get negative 6t plus 33. Awesome. Well, let's move on. Get that out of the way. Get that somewhere up here. Cool. And we're actually going to look at some vocab online. So take a minute. You'll notice in your vocab area right here, I'm not going to write it down on this. I've already done it. You ready? You ready? I've done it. I'm just not doing it again. And this handwriting is better than mine. So write down this vocab right here, elimination. A method that involves eliminating a variable by combining the individual equations within a system of equations. Okay? Pause it. You're going to need time to write this down, so make sure you hit the pause button, and then we're going to move on to the next, because you have some steps I need you to write down. We're going to do a method called elimination. This is the method we're using. We used substitution the last couple days. Now we're going to use elimination. As you can see now on the screen is elimination, and it has 3 steps. Step 1, write a system, so like terms with opposite coefficients are aligned. Step 2, add the equations. Eliminating one variable, then solve the equation. And step 3, substitute the value from step 2 into one of the equations and solve for the other variable. Write the solution as an ordered pair. Go ahead and write those 3 steps down. You'll notice I've given you space right here. Give you a little more space for step 3 to spread out because it can be a little bit longer. But again, pause this if you need to. Ready, set, go. Okay, I'm assuming you've paused it, and we're going to go do something about it. So hopefully you've got those written down right here. And we are going to solve the system using elimination. But what kind of elimination? Addition. There's going to be subtraction later, so I want you to have that there. Okay. This is actually, generally speaking, the preferred method by every student. So the first thing we want to do, step one says, write the system so like terms with opposite coefficients are aligned. So in other words, this is already done for us. You'll notice we've got the x's on top of x's and the y's on top of y's. And both are written in standard form, but look at this. Notice that the y's, we have a plus 5 up top and a minus 5y up bottom. Those are equal and opposite, okay? Whenever we have equal and opposite, here's what I know is going to happen. I'm going to draw a line under this, and we're just going to add these equations straight down. So I'm going to say 3x plus 5x is 8x. 5y plus negative 5y is just really 5y minus 5y, and a number minus itself is what? Let me turn that. There we go, a little bit better. No, that's too much. There we go. It's just 0, so that's gone. And then I'm going to add straight down here, 11 plus 5 is 16. Look at that. How easy was that? Now we're left with divide by 8, divide by 8, x equals 2. We just already solved for one of the variables. Now step number 2 is interesting. It says, step number 3, sub the value from step 2. So this is the value from step 2 into one of the equations. We can pick top or bottom. I usually pick top, and I'll explain why in a minute. For the other variable, right? Or solve for the other variable, write the solution as an ordered pair. Okay, so I'm going to pick this top equation. So for the top, we know that it's 3x plus 5y equals 11. So I'm going to write 3. Instead of x, though, I've already solved for x. So I don't need to write x anymore. I can write 2. And plus 5y equals 11. And I just wrote top so you'd know I did it in the top. And we have 6 plus 5y equals 11. Now we're just going to solve this like we normally would. Subtract 6, right? Get 5y equals 5. Divide both sides by 5. And we know that y equals 1. Look at that. If x equals 2, y equals 1, our ordered pair is 2, 1. Now, the reason I pretty much always plug it into the top is because I'm going to then check it in the bottom, right? I always say check colon and in the bottom. So now we're in the bottom. And in the bottom, I have 5x minus 5y equals 5. But I now know my value for x and y. This is my x, this is my y, right? So I'm going to say 5 times 2 minus 5 times 1 should equal 5. That's the bottom equation right here. So we have 10 minus 5 equals 5. What's 10 minus 5? It's 5. Does 5 equal 5? Yes. Therefore, this is a good solution. This is where those lines cross. Okay? Now let's look at right here. We're going to look at number 2. We're going to do the same thing. Does everybody notice? Now look, the x's are equal, or the x's are opposite, but they're not equal. There's only one x up here and two x's down here. But my y's are both 3's, and they're opposite. So take a minute, pause this, add those together, see what your resulting equation is. All right, back into it. I'm going to add these down. Negative x plus 2x is just regular 1x. The y's, look at them. They're gone. They cancel out. Be careful. A negative 8 plus a negative 8. That's like saying I spent $8 on a credit card and I spent $8 more on a credit card. How much total do I owe the credit card? I spent a total of 16, so I'm negative 16 in the hole, right? And look, that's a single x. We're already solved. X equals negative 16. Again, I'm going to plug it in the top. So what is that going to give me? Well, let's see. my x is negative 16, so I have a negative on the outside. Be careful, there's a negative on the outside, and then in parentheses, I'm going to put negative 16. I always put my x in parentheses. I mean, generally speaking. You'll see me occasionally not, but for the most part, I always put it in parentheses for situations like this, so I can see where the double negatives come in. And then plus 3y equals negative 8. Just writing that top equation. Two negatives make a positive. 16 plus 3y equals negative 8. Again, we're going to solve this like we know how to solve it. And I'm going to have minus 16. Again, negative getting more negative, so that ends up being 3y equals negative 24. Divide both sides by 3, and we know that our y is negative 8. So my ordered pair is what? It is negative 8, negative 16. Now, we're going to check this in the bottom. Check colon. We're doing this in the bottom equation. You don't have to write bottom every time. I'm just doing it for your notes so you know what I'm doing. And we have 2 times our x, which is negative 8, minus 3 times our y, which is negative 16, and that should equal negative 8, right? Ran out of room a little bit there, but we're getting there. And let's multiply this out. 2 times negative 8 is negative 16. Negative times a negative, right? Because that's minus 3 times negative 16, or negative 3 times negative 16. It's going to be a positive, and 3 times 16 is 48. And hopefully, that is going to equal negative 8. Now, if anybody's watching, you're going to notice something's wrong here. That's not going to equal negative 8, which tells me I did something wrong. So I'm going to go back and look over here. Can anybody catch what I may have done wrong? Look at my x and y values. What did I do? And I leave this in here because, honestly, you guys need to know I make mistakes too. What happened? I switched these around. That's my y value. That's my x value. This really should have been the point negative 16, negative 8. I wrote it backwards, and that's going to change everything. So now let's do this check again, and that's the purpose of a check. Say, hey, something's off here, because negative 16 plus 48 is going to end up being positive 32, which doesn't equal negative 8. All right, so I mixed these up, so that means I should have had, really, let's check it now with the right answers, 2 times negative 16 minus 3 times negative 8 equals negative 8. Let's see if this works a little better. 2 times negative 16 is negative 32. Negative 3 times negative 8 is a positive 24, which hopefully that equals negative 8. And guess what? 24 minus 32 is negative 8 equals negative 8. Boom. Now all's right with the world. See how we use that check to catch a mistake? That's the whole purpose of a check. It saved my bacon, and it might save yours. So I encourage you to always do them, even if they're not asked. Notice I never asked for these on this, but if you're ever not sure, that is the way to check it out. All right, pause if you need to. We are moving on.